for not being able to do them because it doesn't matter what it looks like. Mathematical principles are still in play. For example, if I ask you to do addition with Roman numerals, the symbols would look different, but the concepts would stay the same. So there is no reason that KLMNOP should not be done because they are exactly the same as what has gone on before with some slight tweaks that you should be able to figure out. Now, what is going to happen is we are going to, of course, do these 6 right now. I am going to watch all of you go tick, tick, XX, tick, tick, not actually mark it. But what is actually going to happen, of course, is you're going to fill them in as I do them because nobody did them for actual homework. Now, the 10 people that actually did it are going to get all mad and be like, I did it. And I'm like, hey, great, you did. Good for you. Well done. Gold star for you. But the majority of the class will not have done it. So, no big deal, right? Right. Then you're going to get some work today to do with the 2 types of factoring that we have already done. All right? There are 2 more types of factoring that you are going to see over the course of the next couple of days. One of them looks and starts extraordinarily easily, but can get a little... That's what we're going to do tomorrow. We're not going to take the whole day to do it because tomorrow's Friday and I have some, like I say, I found some more games that I like to play, so we'll play them. All righty? But first, today's stuff. Now, you look at K and you say to yourself, self, I don't know what to do because there's an extra variable there. But of course you do know what to do because if that wasn't there and that wasn't there, we would need to multiply to what? Negative 28 and add to what? 12. Is it 1 and 28? Of course not. 2 and 14? Yes. How do 2 and 14 get me to 12? Well, 14 minus 2. So, of course, it is x minus 2 and x plus 14. But, of course, there's a y there. So you say to yourself, self, if I were to FOIL this out, how would I make 2 times 14 give me 28y squared? Well, I would just put a y there. And now I would be done. So, if you didn't do that, check it. Now, as always, every question you will ever be assigned by me in math, you can do. You have the tools to do it. You are either unwilling or unable to find those tools in your brain, but they're all there. So let's look at L. L looks a little weird, but L also looks a little similar. In L, I of course see a squared at the beginning. Oh, I know what to do when there's an a squared at the beginning. But I see a b cubed at the end. Well, I know what to do when it's a square at the end. So what could I do? Of course, what you will do is you will notice b, which is a common factor, yes? And just like all of you remember from that first day we started factoring, there's something that we are always supposed to do whenever we can do it. And that is greatest common factor factoring. All of these will give me a b. So the b goes to the front, and now I have a squared minus a minus 20b squared. And now, of course, it's super easy, because I know I need, yes, Braden?
The middle one, it should be
AB, thank you. Yes, AB. Now, of course, it is super easy, because I know I need to multiply to negative 20 and add to negative 1. And, of course, it is... Even if you didn't do it, you, of course, can now tell me what the factors of 20 that add to negative 1 are. 1 and 19 will not get me negative 1. 1 and 20 will not get me negative 1. How does 1, here is 1, and 20 get me to negative 1? What is it, Addison?
negative 4, negative 5.
Not negative 4 and negative 5. That would multiply to positive 20. What is it, Amal?
4 and negative 5.
4 and negative 5. So, of course, I know it is b, a plus 4. What kind of 4? 4b, because I need a b squared. and a minus 5b, because I need b squared. Now I look at m and I say to myself, self. That shouldn't be crossed out. That was supposed to be highlighted. Self. X to the 4th. That's weird. But when I look at the previous one, I see x squared got me x and x, because Mr. Myers has said 1,000,000 times that factoring is the reverse of multiplying. So x times x gets me x squared, right? So I must need two numbers here that will get me x to the 4th, and they must be the same. So what is it? It is, of course, x squared and x squared. Then x squared times x squared gets me x to the 4th, right? Now after that, does anything change? I need an x squared. I got some, so I don't have to worry about that. And then this looks pretty normal. I'm going to multiply to 50 and add to negative 15. What is it? Negative 10 and negative 5. And then I'm done. Yeah? Now, n is written very weirdly, because in the real world would I ever write plus 0x? I would never write that, right? But it's there for a reason, because that makes this look just like that, right? So since they look the same, we could apply the same principle, right? Which means I would need to multiply to what? Negative 9. And add to what? 0. What are the factors of 9? 1 and 9. That's not going to get 0. And 3 and 3. Oh, that'll get me 0. How? 3 minus 3. So it's x minus 3, x plus 3. Yes? Of course it's just difference of squares, Gersa-Hill, but I haven't gotten to that in grade 10. It's possible that maybe you've seen that in grade 9, but not everybody has. And even if they have, I guarantee they've forgotten it, which is why I'm showing you this first. Because as you well know, I never show a shortcut first. I always show you why it works. That's why it works. So in a few days, when we get the difference of squares, I'll be saying, flip back to page 64. Remember those? And then you'll all go, oh yeah. Does O look a lot like N? Okay, so I know I need to multiply to 625, and I need to add to 0. Now, hopefully you will see, hey, wait a minute. When there was a 0 in the middle and that was a negative, I just used the square roots, right? So what would I do here? Square roots again, 25 and 25. While you're waiting for me, those of you that did not do letter P, do it now. Go for Myers. No problem. Score. Thanks. Bye. What is the answer? I know you know, Garcelle, because you did it. So what is it?
X plus 4 and x plus 4.
And of course, that way is more simply written, you could argue, as x plus 4 squared. Do I care? Am I that persnickety? Is that the type of thing I decide to end my day on? That's the battle I wish to fight? No. Everybody cool? Ooh. Reconnect. So, we find ourselves at the end of the learning process of two kinds of factoring, right? Okay. So what you are now going to do, and I don't know why the book looks like this. The next page says assignment, and then the page after that says practice. That seems odd to me. I don't know why that is the case. Obviously, we should do the practice one before we do the assignment one, right? And there's a reason for that. When you get in the practice one, you are going to get to 8, 9, and 10. and you are going to have trouble with them. Okay? That's cool. You can even leave them blank if they stress you out too much. But again, I have warned you, you do have a tool to figure out 8, 9, and 10. I'm going to give you a better way than what most of you are going to do, but not until you try it. All right? So it is not a quiz. You can use your books. You can talk to your neighbors. But I want you to do work on page 66, and we're going to show the right answers and most likely a better way to do 8, 9, and 10. And I'm going to do that in about, I'm going to check on you in 15 minutes, but I imagine it's going to take longer. All right? Go. First one's just like what we've already been doing, but it's got a Z instead of an X. And sometimes you kids have the nerve to say, oh, no, how do it's a different letter. Which, of course, makes me want to take my magic pen and stab it into my eye. None of you would ever dream of saying that to me, would you? Of course not. So this we need to multiply to negative 40 and add to 3. And what is it, Emma?
8 and negative 5.
It is 8 and negative 5. So it is Z plus 8 and Z minus 5. We live in Canada, so it is Z. Because Z is how it is said in England, where the language English was invented. Now, I know that's a stupid reason to say Z, because, of course, the people in England say a lot of words differently than we do. For example, what do they call that really thin metal stuff that you can use to cover food? Aluminium foil. What do they call the place where you perform science experiments? The laboratory. What do they call cigarettes? Back to math. So this one, I got to multiply to what? 8. You guys are seeing this happening, right?
Yeah. It was higher.
Because we can't do How many times are you going to try it? Change your color. Try it again. I'm sure it'll work.
There it is. But it moved down by 4. Quality products from your local favorite mega corporation, Microsoft. What do we got? What is it? What is it? What? 4 and 5. Y plus 5. Y plus 4. Now, none of you would ever dream of writing this and asking me if that blue one was right, would you? Because it doesn't matter. Of course the blue one's right. It's the exact same factors. Yes, Emma, I agree with you. All energy drinks taste like donkey urine, no matter what anybody says. Now, this is when somebody says, how do you know what donkey urine tastes like? And I say, how do you not? One of the most famous tennis players in the world, I can't remember his name. He's one of those guys from Bulgaria or something. It might be Milos I don't know, right? Tennis is lame. It's not lame. Tennis is awesome. Anyways, there's this Serbian tennis player, and I can't remember who he is. Yes, him, that guy. No. Put a pin in that.
Answer in German.
Go for Myers. Bye. You're not in trouble, just go. Office. Anyway, that dude, when asked, why are you so good at tennis? He says, it's because of this. Blah, blah, blah. I can't say the word. Go to the office. Okay? You're not in trouble, don't worry. Oh, the main office, where you walk in the front of the school, where all the principals and things are. Oh, she knows where the office is. That guy says the reason he's so good is because of the cheese he eats. That cheese is made from donkey milk. And that dude likes that cheese and swears so much by his donkey milk cheese that he bought a ranch of donkeys to make his own donkey milk cheese. Now, all you are like, donkey milk, gross. Really, when you think about it, why is donkey milk any grosser than cow milk or goat milk or any other milk you could get? Anyways, back to math. Now, this question is a grade 9 question that is bothering me a lot, because we've already done a unit on exponents, and more than one of you think x squared plus x squared is x to the 4th. I'm a little bit concerned by that. I lie. I'm a lot concerned by that. I lie. It's a good thing I'm wearing glasses, or my pen would already be stuck into my eye. Use your heads. You're smart kids. All right? Remember when I did algebra tiles and you were all like, oh, I hate them. We don't need them. We know how to do it. Obviously you don't if you think that is true. Because, of course, that is the algebra tile for x squared, yes? There is another x squared, yes? How many x squareds do you have? I have 2 x squareds. Do you see an x to the 4th anywhere? Of course not. So this is 2x squared. Then my x squareds are gone. Then I've got negative 3x's and negative 9x's, which is negative 12x's. Now they're gone, plus 8. Now, of course, you see 2, 12, and 8, and you recognize you can divide out a 2. X squared minus 6x plus 4. And then you would say to yourself, self, I need to multiply to 4 and add to 6. Are there any numbers that do that? No, of course not, because 2 times 2 is 2, or is 4, but 2 plus 2 is 4, so you can't do it. That doesn't look very clean. That doesn't look very clean. That doesn't look very clean. That doesn't look very clean.
Mr. Myers.
She does it all the time. Mr. Hirschman's like 10 years younger than me, taller, skinnier. I'm better looking, but, you know, don't be that way. All right.
How did you get negative 7 next to it?
There, that's a 12. Because 7s, of course, have the cross. So you don't make that mistake. All right. So that's the answer there. It's done. Now this one, again, same thing. A bunch of you are trying to factor this. But 3k squareds and 15 more k squareds is how many k squareds? 18k squareds minus 18k. You're smart kids. 18 and 18, k and k. Divide by 18k. 18k goes to the front. K minus 1.
Wait, what?
It's GCF factoring. I will. What do you see there and there? What do you see there and there? Right. I got 18 of them, don't I? 18k squared minus 18k. Now, it says right there 18k. And it says right there 18k squareds. Now, of course, the GCF here is 18, 2Ks and 1K, so 18K. So then I would divide by my GCF, just like that whole lesson we did 2 days ago. I would write the GCF at the front, and then I would write quotient 1, K, quotient 2, negative 1, and I'd be done. Please notice, nothing new. GCF here. GCF of 24 and 18. 6. How many X's can I get out of the first one?
3.
Well, that's the answer, is 3. So you jumped the gun. How many Y's? 1. Then I divide by my GCF. 6x cubed y, 6x cubed y, and then I write my GCF at the front. 6x cubed y, and what are the answers? What's this? 4x minus 3. Done. Now, Emma, I'm not picking on you. I'm just wondering why you're able to kick this one's ass, but then this one you're like, what?
Because I didn't realize I didn't do that math. I didn't realize to add the 3K.
Oh, okay, you forgot to add the
I
3Ks.
thought everything was divided by 3K.
Okay, now, that's actually good that you thought that, because look what happens. So let's say, just like Emma, you forget to gather these, right? You forget, you're like, So then you're going to say to yourself, just like Emma said, she's going to divide everything by 3K, right? So 3K is going to come out to the front, and then she's going to get K plus 5K minus 6, right? Right? And then hopefully she's going to see, hey, wait a minute, there's 1K and there's 5 more Ks, right? So then she would have 3K, 6K minus 6, and then hopefully she would see, oh, wait a minute, 6 and 6. I'm going to bring that 6 out here, and just like with square roots, 6 times 3 would get 18, and you would have gotten there anyway.
I did not do that. I just ended up.
Yeah, I know you did. And where I'm going with this, Emma, is when do you stop factoring? When there's nothing left to do, right? And then number 6 is we just did a bunch of them. I need to multiply to negative 81 and add to what? 0. What is it?
9 and negative 9.
X plus 9, x minus 9. And then this one. Now this one's tricky. It's similar, except instead of x squared, I have x to the 4th. So what is my first one going to be here? X squared and x squared, right? And then what's this going to be? Plus 16 and minus 16, right? It'll catch up. Now, there it is. Now, at this juncture, this one is done. But after tomorrow's class, you would be able to do something with that. So you would go further. Everybody cool? Now I'm going to rewrite this in such a way, and maybe you can figure out how you would do the next step. This can be rewritten as this. Right? So what would you do with that now? Because that looks a lot like 6 and 7, doesn't it? What would you do with this? Yes, Hannah? Multiplies to 16 and adds to 0. And what is it? $81, 9, 256, 16. 16, 4. X plus 4, x minus 4. That is where you're finally going to end up. Now we get to 8, 9, and 10 that are weird. And I told you, you have the tools to deal with them, right? I'm going to show you, if you even got to 8, I am betting that 90% of you saw this right here and went, oh, okay, that's x squared minus 2x. If you didn't get to here, is that what you would have done? I'm betting 90% of you would have done that. And then you would have gone here and gone plus 3x minus 6, right? And then I'm hoping that you would collect those like terms and get x squared plus x minus 6. And then you would factor that, right? Everyone agrees, yeah? And of course, you would get multiply to negative 6, add to 1, and you would know that it was 3 minus 2, right? And you would get x plus 3 and x minus 2, correct? Everyone agrees, yeah? Now I want you to look at something. Look at what I've highlighted in blue. And look at what I've highlighted in yellow. See? What math is happening right there? Multiplication. What do these brackets do to x minus 2? No. No. What do brackets do in math? Really, ladies and gentlemen? No. What do if I just gave you this, what are those brackets doing? Addison. Separating it from the rest of the equation. This is one thing, isn't it? So doesn't that make this yellow thing here a single factor? And doesn't this yellow one have the same factor? So doesn't that make x minus 2 a common factor? So let me show you, I submit to you another way to do this is x minus 2 plus 3 x minus 2. X minus 2 is the factor in both of them, isn't it? So isn't it a common factor? What do we do with our common factors? We divide by them, and then we write them at the front, yes? And then we write the quotient, cancel, x, cancel, plus 3. And you can get there in one step instead of doing all this. Does everybody see how that works? Yes, Jacqueline.
What about when it's not common with 10?
I'm getting to that. So now that I've shown you a short way to do 8, can you apply that to 9?
Yeah.
Of course you can, because you see that that and that are common, right? So the common factor goes to the front, and then I've divided by the common factor, cancel, 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 and I get 2a plus b, without having to send it all the way through this process. Now, is it all right to send it through this process? Of course it is. You'll get the right answer as we just proved. But it'll take a lot longer. Everybody cool? Now, Jacqueline says, okay, Myers, shut your face. What's going on here? Because these look suspicious, don't they? Now that you have seen 8 and 9, the trick, 10 should strike as something's up there, yes? But in the first one, which I'll highlight in yellow, it's a positive 2 and a negative 3, right? In the second one, which I'll highlight in blue, it's a positive 3 and a negative 2x, yes? Okay. Yes, Gersil? Sure. Why? Okay. So Gersahil is saying, wait a minute. If I make this 5 positive, then doesn't that mean I could flip these signs? And he's absolutely right, but you have to know why. What is the number that is a factor of every single other number? 1. Okay. So that means 1 is a common factor of 3 and 2, yes? So I could divide by 1, agreed? Okay. So if I divide by 1, I bring out a 1. 1 times negative 5 is still negative 5, isn't it? Okay. What if I divide by negative 1? Is negative 1 a factor of every single number? Negative 1 times negative 3, what does that get me? Negative 1 times negative 3, what does that get me? Positive 3, which is what I needed, right? Negative 1 times positive 2, what does that get me? Negative 2, which is what I needed, yes? So can I always remove a negative 1 as well? So I take out a negative 1, now I have negative 1 times negative 5. What does that get me? Positive 5. So now I have x, 2x minus 3, plus 5, and what's 3 divided by negative 1? Negative 3. What's negative 2 divided by negative 1? Positive 2. Now, what do you see? The same factor, which means it can go to the front, And then, what is the quotient? X plus 5. Does everyone see? It's a handy little trick, right? Because we haven't changed any values, have we? We've just changed the way it looks. And I want to show you this. If I have negative 5, 3 minus 2x, and I distribute that, what is negative 5 times negative 3? Or negative 5 times positive 3? Negative 15, right? What's negative 5 times negative 2? Positive 10x, yeah? Everyone's happy with that, right? What is 5? Now remember, I took out the negative 1, right? To change this negative 5 to positive 5. What's 5 times 2x? 10x. What's 5 times negative 3? Negative 15. 10x, 10x. Negative 15, negative 15. Does everybody see? Numbers can be moved around to work and still keep the same value. You have done this a crap ton in math, even though you don't think you have. What do I mean by that? Mr. Myers, you're a liar. We never have numbers that change and don't change. What is 2/3 plus 1/2? 4/6 plus 3/6, isn't it? Do those numbers look different? These numbers look different. Have their values changed? No. You already know you can do this in math. You just haven't had it connected to anything other than adding fractions. So we can change these values. We can change the looks and not change the values. Everybody cool? Now, at the bottom of this page, there's 2 practices of multiplying, right? Remember, what does this mean really? X plus 3, 3 times. And I recommend you start where? With any 2 of them. Either these 2 or these 2. And you leave the other one and then you redistribute it later. Okay? And then this one is just normal. Your work for the rest of the day and for homework is the previous page that should have been this page. Page 65. And it says assignment. So what will happen tomorrow? It will be marked. Now, I am not unreasonable. When you get in here tomorrow, I will give you a bit of time, like 5 minutes, to check over with your neighbor, somebody you trust, to see if you've done this right before we mark it. But again, if you just copy their answers, tell me you did perfectly, and then get 0 on the test, what does that do to our relationship? It sours it. Please do not do that. All right? Assignments aren't worth that much. It's not worth spending 3 more months in here with me not believing a word you say. Okay? Go.